Okay, let's see. Monday, searching pi. What I wanted to talk about today were we talked a little bit about how you're actually going to search the digits for the key. What I'd like to do is just talk about some baby steps about starting from 0 or nothing and building your way up to a functioning program. Then we'll break and Rebecca will do her thing. And then I want to go back and just continue playing around with the textual analysis that we started earlier, where we were doing word counts. I want to do a couple of other slightly more interesting analyses. And then if we have time, I'll start talking about processing. You'll notice that the next homework is currently up, and that'll be due a week from Monday. And we're going to step away from C++ for a while and use a new language called processing that has a very C++-like structure. It's object-oriented, and for loops look the same, and while loops look the same, and the data types are all the same. So it's really it should be a fairly straightforward transition. All right, so without further ado, let's talk about baby steps in getting the Searching Pi program up and running. So I think a good place to start is to get the interface working. So the interface here is essentially a repetitive prompt for a key. And we decided already on Wednesday that the key was going to be stored in a string variable. So this will essentially be a while loop, and it'll just run indefinitely. And we'll ask for a key. We'll search for the key. We'll return the results, or report the results, I think is probably a little clearer. And start over again. Now, you've worked with interfaces like this before, but I just want to remind everybody how this is going to work. You prompt for a key. The person types the key in and hits enter. C into a string. Probably a good name for that string would be key. Take that key, search. Now you go back up to the top. One of the things that I've asked you to do is to make this program stop when the user does not enter a key. How are you going to make that happen? C and how? Andrew?
I was going to say we need to use we learned a while back like C and peek or whatever.
Yeah, the peek. Okay, so you can peek and see if what's sitting out there. What do you look for? You look for a \n, the carriage return, or the n-line character, right? If that's going to be your trigger to stop the program, Danielle?
Oh, you need I wasn't raising my hand.
Okay.
You need the ignore.
Yeah, okay. So if my trigger to stop this thing is going to be a \n, then every time I get a key from the user, I have to dispose of the \n, because remember how the interaction goes. Prompt for a key, clickety-click key, enter. Cin grabs the string, but it leaves the enter key, right? If you don't get rid of that enter key, the next time around, peek is going to see it, and it's going to quit. The best way to think about these kinds of prompts is to just make sure that you have an empty input stream. Whenever you're done with an input stream, whenever you are conceptually done with an input stream, empty it. Go ahead and eat all the characters that are on there, get rid of it. That way, the next time you go to the input stream, you're guaranteed to not have any stray characters there that might confuse your logic. An easy way to empty an input stream you could write a little function. You could wrap this in a little function. I'll just give you the basic logic. You can do something like while cn.peak is not equal to \n cn.ignore. What this will do is dispose of characters one at a time until what?
So there's not one there.
Until I encounter the return character. So if I truly want an empty input stream, this is a 2-line program. I'll do one more ignore. And these two guys together will empty the keyboard input stream anytime you call them together. The while loop goes ahead and disposes of any characters that are there except for an enter. And then that extra line gets rid of the enter key, and there are literally, after these 2 lines, no more characters waiting to come in. And I will often put this guy in a little function called empty stream or clear stream. And I'll just call clear stream. It's a void function. It has no arguments. So void, very simple, and just call it whenever I want to clear the stream. If you want to do that, go ahead. So, ask for a key, clickety-click, enter. You read the key into the string. Or just enter, and what do you do if you see an enter key? I want this program to end. How do I make that happen?
That's exit.
Exit or break. Right? I'm in this while loop. If I break out of the while loop, the program's going to end. The only thing keeping the program going is the while loop. Over and over and over again. So exit 0 if you want to do that, or break. Depends on what you want to do. Like when would it be good to use break versus exit 0? Danielle?
If you want something to happen.
After the loop, exactly. Yeah. Exit is going to shut that program down right then and there. Break gives you the opportunity to do something afterwards, like thanks for using search pi or something like that, right? So that's the difference. So what I would do to get this thing going is I would just write an interface that asks for a key and repeats the key and exits when it's supposed to. Right? If you can get that little baby step going, right, you've basically got 90% of the interface. So a good place to start this would just be a simple ask for a string, repeat the string back to the user. Ask for a string, repeat the string back. If the user hits enter, the program exits. Okay. Once you've done that little baby step, you can start working on the search function. And again, I would encourage you to write the search function, as we discussed on Wednesday. This is a function that's going to return 0 if it fails to find the key. Otherwise, it's going to return the key position, the first occurrence of the key. And it's going to take 2 arguments. It's going to take the key as its first argument and the digits of pi as its second argument. We talked a little bit about the logic of how you do that key search. If you have specific questions about that, I'd be happy to entertain them. Otherwise, I'm going to leave that to you guys to flesh out. Danielle?
As a question about the above and beyond, if we were to write a program that looks for the table, would that be okay?
To automate that process, sure. Yeah. I can think of a few above and beyonds, like instead of finding the first occurrence, find all occurrences. You could have it, I don't know, find backwards occurrences. You could ask it to find the first palindrome of length 5, right? What's a palindrome? Same thing forward and backwards. So take a 5-character window and slide along and have it stop when it encounters a palindrome, like 1, 2, 3, 2, 1. So lots of different things that you could do. All right. Any other baby steps that I wanted to mention? Another baby step is to open the digits file and read the contents into a string. So we talked about the open syntax. Let's pretend that we have a file handle, say an if stream. And let's just call it input. And you would attach it to some file name, like that. The syntax for reading the digits of pi into a string is surprisingly simple. Just input digits, where digits you've already declared as a string variable. Such a tiny line for such a massive amount of data, right? This one line will load all million digits into the string digits. You might be a little bit concerned about overflow, but rest assured this guy can handle a million digits. A million digits, as we talked about last time, is 1,000,000 bytes, 1 megabyte. How much memory is in your laptop? Usually 4 gigabytes or so. So you're not even close. Not even close. If you were getting close, right? If you're searching, say, the first 4 billion digits of pi, and lots of laptops only have 4 gigabytes of RAM in them, and frankly, you can't access all 4 billion anyway because the operating system is using some of it, and other programs that are running on your laptop are using it. So at most, you're going to be able to maybe get your hands on 3 billion of it. If you're bumping up against that edge, you've got to do much more sophisticated programming to make that happen. One approach is to leave the file on the disk and just load in chunks. Load in a 1 gigabyte chunk and search it, and then throw that away and load in the next gigabyte chunk and search it, and then chunk by chunk by chunk, load it in and search. That process is necessarily going to be much slower than loading the whole thing into RAM, but you're limited by the physical capabilities of your laptop or your computer. So how do you know if this is working, right? So what's a nice baby step way of confirming that I've successfully opened the file and loaded it into the digits string? Maybe not. But print enough characters to convince yourself. So maybe you could just look at digits. You could look at digits 0. What should that be? That should be 3, right? And just print out specific characters that you know already. What's digits 5, digits 10? If those guys are all working, you can rest assured that digits 999,999 is also there. Okay, and then I don't know that I specifically said this, but then write and test, search. These are sort of the three big components. Then glue them together, and you've got a fully functioning program. Another thing, another above and beyond that I thought of was you could use the argc stuff to get the file name from the user. So then you could do something like ./a.out digits.txt, and that, of course, that string would go into a.out. You would open that file and load those digits. That way, if you want to run your program not on the first million, but the first 10 million or the first 100 million, you don't have to get in there and muck around with your program. You can just change the file name to the appropriate one holding the appropriate digits. That would be above and beyond also. And you can bounce back, I think, 2 days and read and look at the notes about how to use argv and argc. Okay, any questions about that? I'm out of town starting in about 45 minutes, and I'll be back probably Sunday morning. So I will be incommunicado for a while. Madeline.
Can I just ask a question about something earlier that when you're doing input stream / the key, are those two separate events? Like, would you clear the input string after you've recorded the results, or?
It doesn't really matter when. You just clear it either right after you've gotten the key or right before you're going to get a new key. It's just either before or after you go out to the keyboard to clear it. And this is a little more sophisticated than is necessary. All you guys really need to do is handle the \n. And so you can just do one peek and ignore. Why this is a little bit more robust is, what if the user at the prompt types 3141 and then puts a space in there and then hits enter? This guy will be a little more robust. It'll go out there and throw away the space and throw away the enter key, and it'll be ready for the next run. But I'm not asking you to be that careful about error checking. I'm going to use your program correctly. I'm not going to throw extra spaces in there, and so it's not really that big a deal. But in a more robust program, you would use this quite a lot to trap errors, trap extra characters that are put in there by accident, stuff like that. Other questions? All right, Rebecca. Let's do your thing.
I need my email.
You need your email. We can do that. Can we do that? Yes, we can do that. I need to log out of my Google thing, and I am logged out. Okay. This is interesting.
Yeah. I knew what they were before I requested it, so kind of.
Are you getting in? Yes, you are.
Fine. Oh my god. Okay, I'm fine.
Okay. Go.
Okay, my question is, what is an exoskeleton and what are they used for? And at its most basic form, an exoskeleton is like an external skeleton that supports the body. So like hermit crabs have shell, they're an exoskeleton. We have internal skeletons because our spine supports our body and it's inside us. They are used today, they make artificial exoskeletons, which are like robotic and made from metal and really heavy. They're used for armor, machines for medical and industrial purposes. This is more like really heavy lifting that you couldn't do on your own. You put on this like suit and it helps you lift things that are really heavy. They're used for the military, nurses to help lift patients that they couldn't do on their own. But probably the most interesting aspect is rehabilitation and support for disabled people. So exoskeletons can be used for paraplegics and paralyzed patients who can no longer walk, and they actually allow them to stand up and move around again. So this article is basically about a specific exoskeleton that's been developed that's helped people move. This one they made that's lightweight and it like responds to movements. You basically put it on over your legs and it walks around for you. They're pretty pricey. This one's they say that they're about like $140,000 plus annual service fees. This one's like 27 pounds, but they're about 45 pounds. You know, it's still being developed. It's a pretty new technology. And then some limit and design issues is for the ones that require power. Power supply is a huge issue because it requires a lot of power. And then some issues that have been seen are the body adapts to robotic movements. And then, so it just kind of, you lose your natural ability to move fluidly and you lose motor skills. So this isn't necessarily an issue for paraplegics, but if you're using it as like an armor or to lift really heavy things, it could become an issue if you're wearing it a lot. And joint flexibility and general weight of the product. So it's pretty much in really early stages, I've kind of found. But it's kind of cool that it helps people move again.
Any video?
I don't think so. I could look for one if you want me to.
Sure.
I don't know. They're really cool.
And the reason we're talking about this is a difficult programming problem to actually get these things to respond in a way that's useful.
That's what they look like. I don't know if I could find a video in like a reasonable amount of time. But okay. Well, I did Google it. I just didn't look for a video. Do you want one that helps disabled people or just like? Here.
That one's actually pretty good. I've seen that one.
The top one?
Yeah. Although it's 2 years old now. I was hoping for something better, but
I'm sorry.
it's okay. So click in the middle.
Okay.
Or just, thanks.
Exos 2 is more fluid and stronger. I don't feel the strength, but I know I can pick up more. The big deal is that it takes a lot less power at the same time.
Sorry.
Incredibly strong, and the interesting thing is it doesn't feel any different if you put 150 pounds on the back or if it's unloaded. Exos 2 is more fluid and
I think
stronger.
some of them, they work where they're not.
I don't feel the strength, but I know I can pick up more.
But it's like,
The big deal
Yeah.
is that it takes a lot less power.
I went
at
into the
same time
technology which I
as it's
didn't
stronger.
really
We
understand.
reduced the
And it
power
basically
consumption
said
by
that it sucks up a
50%
lot
by
of power
comparison to
really
Exos 1, and our target is 20% of what Exos 1 used. We wanted to basically reduce power
I know, I
consumption
think they're really cool.
to make it more practical for non-tethered use.
Here, do you want me to keep playing or?
If you push on the board, like, I'm never gonna be able to break that, but then you line up and do it, and
Yeah.
away they go. What?
So yeah, I don't know. What?
It'd be fun to have one.
It'd be, yeah, I mean, they're really expensive, so obviously if you have that money to just sort of throw around on a robotic suit, go
Yeah,
for
and
it.
so like I was saying, the hard part here is you've got the natural motion, like the guy's
Yeah.
punching through this wood. You've got the natural motion of the physical body, and you've got to somehow, it's a programming problem to turn that into motor action on the suit itself. And we've seen just dramatic advances in the last, say, 5 to 10 years. it's similar to, you guys have seen the Segway scooter, right? And I know it's sort of dorky, but the thing that's interesting about the Segway is that it is dynamically balanced, right? It stands on those two wheels, and that thing wasn't possible 20 years ago because there was no processor that could read the gyroscope and correct the balance quickly enough. But with the advance of processor speed, now you have the ability to, type in the one-wheel motorcycle.
Okay.
This guy's in Portland.
Oh, this is a full story.
Yeah, just click it anywhere and you'll see him sort of. See, click while he's like out on the road.
Yeah. Ah! No, I lost it.
This is like way better than a Segway.
Well, he might be moving.
So I'm always safe when I'm able to ride the bike, and I'm just simply ride off.
I mean, it seems he just gets out in traffic, so it seems to be no problem.
This is a personal transportation product that's in between the cracks of urban
What?
transportation.
I don't think he's marketed it yet at all, and you can tell he's in Portland.
Yeah.
Yeah, the rain. Yeah, the rain, and you probably could tell me what street that is. Some people in here anyway.
Not me.
Anyway, thanks.
Yeah.
Faster processors enable this kind of thing to happen. Logging out. Good.
Yeah.
Okay, let's go. Let's keep playing around with. Let's keep playing around with files and textual analysis. If you watch that video, the guy, it sounds like he has no intention of even trying to market it, which is weird. He just built it himself, and he just tools around Portland.
Why would you ever build something?
Why not? It's fun. Yeah. It seems like fun. I don't know. Okay, where was I going to go? Oh, yeah. And here, and here, and here. So last time we were playing around with a word counter, and we wrote this program that sort of roughly went through and counted the words in these various significant opening paragraphs of texts. The Stranger and Confederacy of Dunces and King James Bible and Moby Dick. Let me remind you, in fact, I'm going to copy this to sentences. Okay, so this guy counted the words, and we can actually see how it worked. We start out with a word count variable and set it to 0, and then we read a word, and we check to see if we've gone past the end of the file, and if we have, we're done. Otherwise, we increment the word counter, and when this loop exits, in other words, when it reaches the end of the file, we've counted the number of words. And I uncommented the cout command there so that we could see what my program was considering a word. And it's not bad. I would say that this word count is fairly accurate. You'll notice that me with a period is not quite a word, but me is a word, and we're not over counting it in this process. So, you know, I think we're in the ballpark of having an accurate word count. Some of these were a little less, I don't know, let's look at a different one here. Even that one's not too bad. There's nothing in there that I would say doesn't count as a word. There are some ambiguities. Is that a word? I don't know. And frankly, these are decisions, whenever you see word counting programs, these are decisions that the programmer had to make at some point. Okay, what I wanted to do was see if we could come up with a way of not counting words, but counting sentences. And possibly another one would be see if we could figure out what the average word length was in the paragraph. So let's play around with those two ideas. Let's first see if we can figure out a way to count sentences. So we've got this thing that goes through and pulls out the words. In order to detect a sentence, we have to have some signal for when we have a sentence, and we have a signal, right? It's a period. How are we going to turn that into an algorithm? Ideas? And maybe while you're thinking, I'll let you stare at this output. Oh, only one period there. Let's do. There's a couple periods in there. Ideas?
We might do something.
Andrew, go ahead.
Is there some way to search for a period followed by a capital letter?
So you don't want to just go with a straight period. You want to go for a period followed by a capital letter. Yeah, that's an interesting. I think, yeah, that would be. I was going to start off simpler and just look for period, and then work my way up to that. But
I was going to say we could do something like we were doing with the clear function. Just we go and the next character is keep for the next character if it's a period, then that's our cutoff. Something along those lines.
Okay, so you could go through it character by character instead of grabbing word by word. Sebastian and then.
Yeah, well, I was thinking, if there's an ellipse or something, you should write something in there that doesn't count things with ellipses.
Yeah, right. ... 3 sentences, possibly. And Becca, comment?
I was just gonna say that, like with Mr. or something like that, you have like a capital letter after the period.
I was going to say do a space.
Yeah, Mr's going to have a space, then a capital, possibly also.
Like you have word, period, word.
Word, period, word. So you begin to see how hard a problem this is, right? And to do this correctly, you pretty much have to just build in a whole collection of exceptions. You've got to look for Mr., you've got to look for Mrs., you've got to look for initials, J period, D period, or something like that. And then period space versus period space space. It's, way back when you first learned how to type, possibly they told you to type a period and then space space, and then Microsoft Word came along and said, well, you don't really need to do that, we'll do that for you. And so you can't really reliably ask for a period and then a space space to indicate the end of a sentence, because there are lots of text files where it's just period space and then the new sentence starts. Let's keep it simple and just count periods. Okay?
What about exclamation points or question marks?
Yeah, exclamation points and question marks. Okay, so let's go in here and let's do sentences. So one way to do this, it would be an overestimate, would be to count periods. So we'll say p count. And you could go through this thing character by character. Do you remember how to get one character out of a file? Do you remember the syntax? It's okay if you don't, you haven't used it. The get function. So we'll get a character. So this is going to go through and get characters one by one, visible, invisible, end lines, whatever. We'll get a character. We'll check to see if we've reached the end of the file, and we just want to count periods now. We're keeping it simple. So what should we do if we just want to count periods? Absolutely, yes. Oops. Yeah, that'll do it. And you could say there are PC, maybe sentences. It's a bit of a stretch, but there are PC periods. We can safely say that in the file, and we can use the number of periods as an approximation for the number of sentences. And if you're doing massive textual analysis, an approximation might be all you care about. So let's do that guy. So sentences, figures. So apparently there are 8 periods in Moby Dick. There are 8 sentences. Sentences can be a measure of the sophistication of the writing, or certainly a stylistic measure, right? Lots of long sentences suggest sophisticated, compound ideas. Short sentences, maybe dialogue or declarative statements or things of that nature. Let's run this on all 4. So Camus and Kennedy and King James and Melville. So not really much information there. Again, it's hard to do any substantial textual analysis, any kind of significant textual analysis on one paragraph. The first paragraph may be unusually short, unusually long, whatever. So there's a lot of statistics involved in this as well. Let's talk about average word length. So we've talked about some of the many complications in counting sentences. Let's talk about counting or computing average word length. So let's copy sentences to average word length. Okay, we do have a nice quick way of getting our hands on words. In fact, I should have copied the other guy. Words to average word length. So this guy will go through and count words. It's probably not too terrible of a modification to get this guy to average the word length. Suggestions? Yeah, Carter.
Make another variable and just have it add on, declare it to 0, and then have it add on initialize, and then have it add on all of the word lengths, and then divide it by word count.
So I can literally just count all the characters in the file and divide by the number of words. Okay, so I'm going to sum up all of the word lengths. I'll get a sum variable going. I'm going to read a word. How should I add the length of the word into the sum variable?
Sum equals sum plus word dot length.
Or size, yes. Either one. Actually, length works as well. Okay, so we could do sum equals sum plus word dot length. I'll use yours. I think length works. I think they're both the same. And at the same time, we're going to count the word. Now, at the bottom, we're going to compute the average word length. So let's get a double. Call it average. And down below, we'll just say average equals sum divided by word count. Now, there's a decision to be made here. Let me whenever I divide integers, I need to think about that, right? About whether it's doing what I want. So the question is, do you want word length to be a whole number, or do you want it to be, 7.25, the average word length, or 8.32, even though 0.32 doesn't really make sense as, right? So how do we want to do this? There's no right or wrong answer. Okay, so this will be an underestimate of the integer word length. So we'll keep it as is. Is this going to do what we want, assuming the dot length thing is there, which I think it is? Yep. So in Melville, uh-oh. They can't all be. Yay. Okay. And of course there are flaws in this calculation as well. And it depends just on how precise you want to be. Do you want to go through and just nail every little single possibility that can happen? The English language is pretty complex, and there can be lots of exceptions, and you can spend days writing a good word counter or writing a good sentence counter. Or are you going to be analyzing really large pieces of text where these little exceptions are not statistically significant, in which case don't work so hard, right? Just get a rough cut and compare across texts and walk away. I think we should see what the double version is. Whoops. Now I'm curious. So we'll go down here. How can I make this double? Yeah, let's cast one. And we'll go up and do what did I miss? Which one? Thank you. God, by this time I could have typed it. Okay. So this gives us a slightly more refined look at the average word length. Questions about that? Yeah, go ahead, Sebastian.
So on the string word, how does it already know with the dot length function to look for space? Is that just pre-built in the string variables?
Yeah, let's talk a little bit about this guy. So let me uncomment this original program and let me run it. And so remember, here's the King James text, and then let's look at what the original King James text looks like. So we see down here at the bottom, upon the face of the waters, upon the face of the waters. What's going on is we're using what's called a formatted read. And when you do something like, let's go in here, when you do something like this this is doing what's called a formatted read, and it will look for a string, and it will read the string until it encounters white space or invisible space, and call that a word. And then the next time it goes out there, it'll ignore leading white space, and then read characters until it gets to trailing white space. So this is really nice for kind of chopping the sentence up at the spaces. It makes me not have to work so hard to make that happen. You could do this on your own by doing character reads using .get, and you would just read characters and put them in a string until you encountered white space, and you would call that a word, and then you would do the next one and the next one and the next one. So this formatted reading is doing all that work for you. Other questions?
So that was just by declaring string variable called word. It already knows.
Yeah. So see this input. This guy here will behave in exactly that way if it detects that it's reading a string. Yep. It's very clever that way. Any other questions? All right. Let me just briefly talk about the next homework assignment. So we're going to start looking at processing, and my hope is that this will be an entertaining part of the semester. If you go look at processing, the processing webpage, this is an open source programming environment. It's primarily used by artists at the moment, but I think other people are starting to use this in other areas. I learned about it from Justin Lincoln in the art department and have actually really grown to like it quite a lot. I have written some mathematical demonstrations using processing. Let me pull up one. It's going to be hard to find in this one. Let me go to my default profile. So this is using processing, and I can have this sort of little animation thing here. And this is demonstrating a formula for the sums of squares. So the formula is up here. The sum of the first n perfect squares is n times n plus 1 times n plus a half over 3. And this is an adaptation of what's called a proof without words, establishing this formula. I'm not going to talk about the formula, but what I am going to talk about is this is processing, and it's a really easy way of building graphical programs. We're not going to do anything quite as sophisticated as this. Not that this is all that sophisticated, but this is 3D rendering, and we're not going to do any 3D rendering in this class unless you choose to do it as an above and beyond. We're going to do mostly 2D rendering, and 2D rendering is not boring either. Let's go to the exhibition, perhaps. No, I don't want to go to exhibition. I want to go to... There we go. Basics. Looking for... Yeah, this is a fun one right here. If it'll actually run. Okay, let's go to a different one then. So there's a 2D drawing. I can't sort of move it around in 3D. And there's a little fountain of ping pong balls up here or something, and just constantly generates new ping pong balls with initial velocities, and the initial velocities are kind of random, and there's a little bit of gravity that acts in the downward direction. My hope is that by the end of the semester, this would be something that would be within your grasp. I don't know why some of these don't want to run on my computer. Oh, I can make more than one fountain. Let's see what else we have here. So that just sort of follows the mouse. Oh, and there's a longer one. That's fun. Oh, and that one's sort of pinned down at one end. And that's kind of weird. So what I would encourage you to do, if once you finish the current assignment, I would encourage you to go and download processing. So let me show you the download link here. And we have 64-bit, 32-bit Windows, 64-bit, 32-bit Linux, and then Mac OS X. If you're in doubt about your Windows machine, just try the 64-bit one. If you're wrong, it just won't work. And then try the 32-bit one. Okay, but most people are running 64-bit. I don't think anybody in here is running Linux, so don't worry about that. And OS X, let me know how you do. I don't have a Mac.
I had some issues with that, but I just downloaded like the root version.
And it worked? Yeah, that's fine. Yeah.